All right, welcome to Module 4. This is going to be the beast that is the Windows operating system. A ton of information. We can't possibly cover everything that the Windows operating system does. This whole module is going to be dedicated to learning more about Windows that we built upon from our Introduction to Windows section that we had in Module 2. And we're still going to do a high-level introductory to it, but there's a lot of concepts to cover. We're going to have 5 sections here. Section 1 is going to cover users, logging, and the registry. Section 2, we're going to have common processes and logon activity to know and be familiar with. We'll move into covering some core Windows components and go over the Windows file system. We'll cover Windows protocols and some commands to know, and then we'll wrap it up with Section 5 with trying to explain the beast that is Active Directory. If there's one module that you're going to be paying attention to, it should probably be Active Directory, as it's a common question to be asked on an interview. If you're going for a SOC position or Windows administrator, you got to know Microsoft's rollout of LDAP, which is Active Directory. So we have a lot to get to. We're going to cover these concepts and try and just take it with, the fire hose of information that it is, but I'll try and point out the most important things to remember from each section, and you can kind of just go from there and deep dive into other topics within the sections that you found interesting or might be relatable to you for future job interviews coming up. So section 1, users, logging, and the registry. Starting out with a basic chart here, this is just showing the version history released of the Windows operating system. This is just for workstations. So there's also the operating system release for Windows servers. For workstations, we basically have Windows 1985 all the way back in, yep, you guessed it, 1985, moving up to, if you remembered Windows 95 for 1995, Windows 2000, Windows XP, maybe that's some of us remember XP in 2001, Vista. I'm sure we are all familiar, hopefully, with Windows 7, and then I think we all skipped Windows 8 and went straight to Windows 10, and at the time of this recording in 2023, I would say you're probably running a revision of Windows 10 or a revision of Windows 11. I am currently on Windows 11, and that's the latest revision of the Windows operating system that they have released. So kind of every few years, they'll release a new operating system version, and it will have increased security and additional features and, sometimes a different GUI be displayed, additional features that we've wanted, or just patching and security and more efficient as technology grows and expands. Starting off with a discussion of workgroups versus a domain. So a workgroup, this is going to be a collection of computers, usually fewer than 10 or so, and they're going to be connected to each other. They're going to share resources for their files, printers, and scanners. Think of your home or your small office building. If you have less than 10 employees, these are everyone's laptops that they're using, workstations, etc. They're all on the same LAN, and each computer is individually managed and has its own set of accounts and passwords. For the work group, I want you to associate the terminology of the SAM. This is the Security Account Manager. And the SAM, as we'll see with local logons for a work group logon, the SAM plays a crucial role in authorizing that the username and password are correct to authenticate to that machine. When we switch over to the domain, we're not going to be leveraging the SAM. We're going to be leveraging, hopefully, Kerberos in Active Directory, and we'll cover that concept later on. But one of the key buzzwords that I'd like you to remember for work groups, or if you're logging onto your laptop, you're going to be leveraging the SAM. If you're in your home and you're not authenticating through your work laptop at home to your organization's domain controller. So they require minimal configuration, and just think of them as your basic workstation. The opposite of that is domains. Domains are larger networks, and it's going to be managed centrally by a server called a domain controller. The domain controller is going to hold all of the users' accounts, all of their passwords, and settings stored here on the domain controller, and it's going to provide a single point of administration for the entire network. So here we had 10 computers or less. This can be 10,000 plus. It can range from 15 to 15,000, depending on how large the organization is. But you're switching away from the SAM for security account manager for local authentication, and you're moving over domain to domain authentication, leveraging Kerberos through the domain controller, through Microsoft's rollout of LDAP, which is Active Directory, which we'll cover in a later section. But as we said, typically used in larger networks such as corporate or enterprise environments. They offer a more centralized control and management. They have improved security and easier administration of network resources compared to workgroups. So, a very quick summary here of workgroups versus domains. Workgroups, smaller number. Domains, larger numbers. SAM, Kerberos, more security. You got the SAM. Now we can discuss user accounts versus a service account. A user account is exactly what you would think it is. That's my account that I'm going to use as the user for that machine. It's going to have a username and a password. We can have different levels of permissions and access rights associated to that user account, typically used for interactive logons and access to resources such as files, folders, applications. They're going to be managed and configured through the computer management console or through the user accounts control panel within that device. And it's basically, we are the user. That is the account that's been assigned to us, and another user will have their own user account assigned to them. When we go into the topic of service accounts, this is created for a service or a process that needs to access network resources like a web server, database application. It's got to run some type of job. They're still going to have a username and password for the service account. It can have different levels of rights as well for permission and access. But here we had the interactive logon. Service accounts normally are not going to have to interact to log on and authenticate. It's going to be a non-interactive logon. It's going to be background processing of tasks or services that need to get done on your network. So you may have a service account for job 1, whatever job 1 is. This is the nomenclature that your organization would use, starting with the prefix of SVC or service, or maybe you just have your own prefixes for your service accounts that you create. Instead of a user account, that would just be the name and the domain that I'm on or who I'm authenticating to. So a service account, just think non-interactive. It's running in the background. It's going to do a task or a service to get done on the network. And where here we're talking about managing user accounts through the computer management console or the user accounts control panel, service accounts are going to be managed through ADUC, Active Directory, Users and Computers console. This is ADUC. So if you're able to manage your service account, you're probably going to be leveraging that through Active Directory. Again, that's Microsoft's implementation of LDAP, and you're going to manage your service accounts through ADUC. Covering what a SID is in Windows, this is a security identifier. This is what the SID looks like here. I just went into PowerShell on my local computer, ran this commandlet of get local user, gave it the name of the user that I am, which is myself, piped it to select an object, and I told it to select my SID. It then returned my SID. So let's break this down. The security identifier is a way to basically identify a user and what domain identifier is associated to them and what kind of values are associated to the SID. So from this slide, you can take away that a SID is going to be unique to each user. Each user is going to have their own unique value for their SID. And probably what's important to remember is the last grouping of number here's. This is called your well-known SID. And for the guest account, if you're using the guest account on that computer, it's going to end in 501 always. If you're using the administrator account, it's always going to be the value of 500. And if you're doing something else like a network service, it'll have the value of 20. Probably the administrator, guest account, and then if you see like 1001, 1002, 3, 4, etc., that's going to be a regular user account. So if you can look at a SID, kind of break it down. If this, string of letters and numbers was presented to you on an interview, you could identify it as a SID, a security identifier, and then remember that 500 is someone leveraging an administrator account on that computer. Great. This one is a regular user. 501 for guest. That's probably what you should take away from this slide. If we want to break down the SID a bit further, S stands for the string value is a SID. 1 is the revision level. 5 is the authority value. 21 through the rest of this gobbledygook, that's going to be your domain identifier. And then 1001, that's going to be your relative identifier relative to the user that is the owner of that SID. So definitely would be remiss if we covered Windows and didn't mention security identifiers, what they look like, breaking one down, and then noting that the end value here is something to pay attention to, and that the value of 500 is going to be someone using a privileged administrator account with more rights and access to do something potentially malicious than a guest account or a regular user account. Since we had a slide for PowerShell, and since PowerShell comes out with every latest revision of Windows, it's built into the operating system. We have our black and white command prompt cmd.exe, and we also have PowerShell, the new revamped cmd.exe, which is our nice blue command prompt that we get brought up, PowerShell. We can cover at a high level a quick note on cmdlets. Cmdlets are these values in yellow here for get alias, get process. There's hundreds of cmdlets that you can learn with PowerShell, and it's an additional feature added onto the shell that the regular cmd.exe doesn't offer you. Some of the more common cmdlets that you can be familiar with are get process. So as we see here, this is going to get a process, and I just piped it to execute the next command to say grep, which is grab the string value of Wacom. This is my Wacom whiteboarding tablet that I'm using right now. So on PowerShell, I know that I have it in and plugged on, powered up, so I know that the process is running. If I gave it the commandlet of get process, grepping for the name, I can see all of these processes running with their PIDs assigned to them for my Wacom tablet being leveraged. So get process is going to retrieve information about a running process on the local or remote computer. Example of the command is just get process. Another one is get child item. This will list all the files and folders in a specified location. Get child item for C would then be the equivalent of doing a dir in cmd.exe, and will list out every folder and file beneath the root folder of the C drive. Set location. This can change the current directory of a folder to the specified path. So if I wanted to change into system32, I can do a set location. Get alias. That's a commandlet that is going to list all of the available aliases for other PowerShell commands that you can do. So if we did get alias for dir, let's say I remember dir is how I list all the directories below me for my current working directory that I'm in, but I don't remember the PowerShell command or commandlet to do the same thing of dir. I can do get alias, the command that I know is dir, and it will say, hey, the alias for dir, you can use get child item, which is the one that we discussed here, equivalent of dir. Cmdlets can also be shortened for shorthand notation. So get process, you can also just do GP and then pipe it to whatever else you want. There's shorthand notation for not having to type out get process every time. There's a lot more to PowerShell than we could ever cover here. But if you like working on the command line and you like the Windows operating system, you would prefer it more than Linux, basically whatever operating system is going to hold your attention and interest the longest, please go learn about it and specialize in it. And it's a great tool to learn and master and become efficient in for any aspect of the technology field that you're going to go into is learning PowerShell and being familiar with it. But at a high level, we did need to mention cmdlets and give you a few examples here. Another thing we want to build on that we discussed in the previous section was the Windows Event Explorer. If we remember, we had some core logging that occurs on the Windows operating system for our application, system, and security logs, just pulling those out here for some of the key logs that are stored on the operating system. We can view these in the Windows Event Viewer, and it brings up this pane here. We're going back into this, and the two values that you should definitely be aware of for their values for their Windows Event ID is logon and a logon failure. So a successful logon will have the value of 4624, and a failed logon will have the value of 4625. If you don't want to remember both, please just remember that a Windows Event ID for a successful logon event is 4624. In the field, we don't really even say the user logged on. We usually say, oh, there was a 4624 at 11:22 p.m. for this user on this system. These are the most common ones that you should know. I wouldn't be surprised if someone asked you, give me the Windows Event ID for a Windows logon event, and you should know that it's 4624. A Windows Event ID is a unique numerical identifier that is assigned to an event when it is logged into the Windows event log, so our event viewer here. The event log is a centralized repository for storing information about systems and application events and errors. So you can also have errors, warnings, and informational logging occur. If I just went into the application section here for event viewer, there's different log events that can happen, and each is going to be given its own event ID, which can be used to identify and diagnose problems on a Windows operating system. Or we can set the filter to say only show me events with the Windows Event ID for X, Y, or Z. I want to see someone accessing a network share. That's going to have its own Windows Event ID. I want to see logon failures, logon successes, sharing resources, accessing something, etc. Those are all going to be their own Windows Event ID. The registry. There is a lot of great information within the registry. It's basically the centralized database that stores all the configuration information needed for the Windows operating system. It is the heart of the operating system. It's going to have all your hardware, applications, software, security, user information, local machine information, etc. Everything comes down to the heart of the operating system being the Windows registry. It's organized into a hierarchical structure with 5 main root keys. So far I would know that there's 5 root keys, and these are the 5 root keys here. Am I going to ask you to memorize these? No, but I would kind of be familiar with their names. I would know what the registry is and that there's 5 main root keys within there. And if you could look at this for the first time and not have it be a shock for the next time that you hear about it, if you want to open up the registry on your Windows laptop, you can just press the Windows key and type in registry editor, and it will bring up your registry. It's used by the operating system, device drivers, applications to store settings, preferences, and other configuration data. when you get down into a registry, you pick a key, it goes down the hierarchical structure where you can expand all of these to go into these subfolders within there. And when you get to a value, it will have a broken out, usually a type and value for your key and key values, and it will be stored into the registry in these slots. If you make changes to the registry, that's going to directly change your operating system. If you've ever heard of a rootkit, that's the other buzzword that I would memorize for associating with the registry. A piece of malware can live within the registry that has made it into a value of a key for the registry, and it's going to persist after boot. Rootkits equal persistence within the Windows operating system, and it's going to be contained within the registry. So at a high level, we can walk through these 5 different main root keys. We have HKey classes root. This contains all your file extensions, all the object classes IDs, other object class related information. You have your current users. That's exactly what the name implies. The current logged in user, including desktop settings, application preferences, network connections for that user. HKey local machine. That's going to have all your information related to the local machine for your hardware settings, SAM, security software, system settings, etc. You can have HKey users. That contains all the information for user profiles on the system, including the currently logged on user and any other user that has logged on to that account. So whereas current user is the user who's currently logged on, HKey users will have any user that's currently logged on plus any other user that has logged onto the system in the path. And you will see if you drop this down, if it's a shared resourced computer, there'll be one for Haley, there'll be one for Melissa. Any other user that's logged onto the system will be present in HKey users. And then HKey current config. This contains all the information about current hardware configuration of the system, including current hardware profile and settings for plug and play devices. So we're taking away from this slide that the registry is the heart of the Windows operating system. There's 5 main rootkits in there. We are familiar with some of the names and what's associated with them. And any malware that would live within the registry is known as a rootkit, which establishes persistence as the registry is the core of the operating system and will survive boot and load everything from the registry when the computer starts up, including that malware that's snuck into a key value within the registry.